All right. Today is 3-2 translations. So what is a translation? In the simplest terms, it's if I could take this shape, pick it up, and move it somewhere else. So I can move it over and I can move it down. Okay? That would be a translation. Okay? So a translation moves every point in the figure the same distance in the same direction. That means since everything is the same distance, it is an isometry. That's exactly what that means, is that we're not warping that shape. We're not moving one of those points 2 and the other point 5. They're all moving the same length. Okay. We have some new notation here. Something could look like this. And this tells us that we need to do a translation. So not a reflection like in the last section, but a translation. Each point is going to shift A units horizontally, so left or right, and B units vertically, so up or down. Okay. We could also use what is called vector notation, which we're going to do an example of, where it just looks like X, comma, Y, but this time we put them in little arrows, making it a vector. And what this means is the first number is the horizontal shift, horizontal change, so left or right. And the second number is the vertical change, or up or down. So let's look at what that looks like in an example. Remember, if I write too fast, you can always hit pause in the video. Okay, on this one, we're going to want to go left. Whoops, it's a plus sign, so we're going to go right. Right 3. And down 6, because negative is down and positive is to the right on a number line. So for A, we want to add 3 to the X value and subtract 6 to the Y value. So negative 4 plus 3 is negative 1. 1 minus 6 is negative 5. I'm going to repeat that process. Plus 3 minus 6. So that becomes 1. Negative 2. Plus 3 minus 6 becomes 4. Negative 4. And this one is 1. Minus 6 is negative 9. Okay. So negative 1, negative 5. 1, 2, 3, 4, 5. 1, negative 2. 4, negative 4. And then 1, negative 9. Now notice, it's still the exact same shape. It's as if I lifted up that shape and moved the whole thing right 3, down 6. Okay. Some of you may find it easier to take this point and count 1, 2, 3, and then down 6. 1, 2, 3, 4, 5, 6, and plot points that way. If you do not like adding and subtracting positive and negative numbers, you can also just count if you're given a graph. Okay, says describe in words the translation represented by the vector 4, -3. Well, since that's a positive 4 in the first spot, that means right 4. Negative, and in the second spot means down 3. Again, if your signs were different, it'd be left and up. Okay, so if I wanted to make this shape go right 4, 1, 2, 3, 4, and down 3, 1, 2, 3, there's one new point. Let's do it again. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. There's my new shape. Translated right 4 and down 3. And that is it for your notes.